So this assignment is a lot like yesterday's assignment, but instead of adding, subtracting, multiplying, dividing, we're going to compose, which is the thing that I messed up yesterday. So composing functions, you see f, and then it's not a dot, it's a circle. And we say it f of g of x, and you're also going to compose g of f of x. Now, there's another way to write this which makes a little bit more sense, and it says you take the function f, and the function f is usually written f of x, right? But instead of x, it's f of g of x, which means you take all of g and you stick it in to the f function wherever you see an x. So you always plug the second function into the first. So if you look at number 12, we're going to take 2 minus x and we're going to plug it in there. So we have 2, sorry, I messed it up. We have x squared minus 1, but I'm going to replace that x with 2 minus x squared minus 1. Well, 2 squared is 4. 2 times negative x is negative 2x. We need to double that. Negative 4x. And then negative x times negative x is plus x squared minus 1. Does that make sense? I did 2 minus x times 2 minus x. So x squared minus 4x plus 3. And then we need to state the domain. What's the domain of this function? All real numbers. There's no way to get either undefined or an imaginary number. For the second one, g of f, I'm going to stick this in here. So I have 2 minus x squared plus 1, which is negative x squared plus 3. What is the domain of that? And it would be all real numbers. I want to do one more. You can use the all real numbers symbol. Yeah, that's fine. Let's also take a look at 18. So f composed with g. F of g means we plug g into f. So I'm going to stick this in here. So the square root of 2 minus x squared minus 2. How does that simplify? It's just the square root of negative x squared. What is the domain of that? What numbers can I plug in and still get real numbers? What's that? Any negative, and there's one more number that works. 0. So the way you tell is negative x squared has to be greater than or equal to 0. As long as the stuff in here is 0 or bigger, we're okay. So if I take this inequality and solve it, I'm going to times everything by negative 1. What does that negative 1 do to the inequality? Switches it around. Then I'm going to square root, and I get x is less than or equal to 0. It's actually plus or minus 0, but that's just 0. So my domain would be from negative infinity to 0. Everybody get that? Okay, and then let's do g of f, which says we take f and we plug it in here. So I have the square root of 2 minus x squared plus 2. How does that simplify? So the square root and the 2 cancel, and we get 2 minus x plus 2, which becomes negative x plus 4. So what's the domain of this? It's certainly all real numbers, but we have to be a little bit careful. If I plug in 3 into this equation, is that going to ruin the whole function? Yes. If I plug in 3 here, that's fine. But the original domain of this is x must be, let's see, it must be greater than or equal to 2. You guys see that? So the domain of this one is all real numbers, but the domain of that one is x has to be greater than or equal to positive 2. That domain influences the domain of the original. So when you're composing functions, you have to check the domains before you start. And then that domain is carried on. Even though this appears to have all real numbers, the original did not. And that original is part of the function, so this is the domain, which would be 2 to infinity. Does that make sense? You have to check the domains before and after and compare the two. So if I had a domain where the original domain was, say, 4 to infinity, and the end domain was 0 to, let's say, let's do it this way, negative infinity to 6. So this is the original domain, and this is the ending domain. What is the intersection of those two domains? The only numbers that work are from 4 to 6. Does that make sense? Because you can't plug 3 into the original, and you can't plug 7 into the end, which means it's not, the composition is going to exclude both of those. So the domain of the composition is the intersection of all of the other domains. Okay? All right, you're working on 203B. Good luck.